Hey class, welcome to week 8. At this time in the course, we've worked our way down the waste hierarchy and are getting closer to the bottom. So our next couple topics are going to focus on landfills. We'll do the next 2 weeks, and then we'll get to thermal treatment after that. So even though I tried to put a lot of emphasis on that top half of the hierarchy and preventing waste, minimizing it, diverting it to better things like recycling and organics, we still have a lot of the waste sector focusing on that landfilling piece. And that's because one is we're not ready to shut down our landfills yet. And then two, even once we get to shutting down our landfills, it takes a long time to actually get rid of them. So these sites run for many years. They're continual construction projects. And then even after they're closed, they need to be taken care of for many, many years. So if you work in waste, you're going to be working around landfills, even as we modernize and buy into this circular economy. So that's why we're going to spend some time, a lot of time on landfills. And there's quite a bit that we're going to look at under this topic. So I'll just start by giving you an overview of everything that's coming up. This week, we'll focus on an overview, look at the reactions going inside landfills, construction and operations, and then we'll look at the hydrology piece, which will help you with your lab number 2. And we'll look at the final cover system that's meant to keep the water out of the landfill, and then the liner and leachate system that's meant to keep the groundwater protected from the leachate in the landfill. The next week after that, we'll look at what do we do with that leachate once it's collected. Also, we've talked about landfill gas a little bit, but how do we collect that gas? And we've talked about how do we utilize it usefully already back in chapter 5 along with biogas. And then we'll get to what do we do when the landfill is closed? How do you take care of it? And then how do you eventually redevelop that site into something that's more useful? So we've looked at the waste hierarchy a bunch of times. This one on screen here is interesting because it has, all our conventional stuff at the top of the hierarchy, and then in the bottom we have a whole bunch of different kinds of landfills. So depending on how the landfill is operated, you could rate it higher or lower on the hierarchy. So at the top are landfills that recover and use their methane. Below that, we have landfills that at least destroy the methane to mitigate some of those climate change effects. Below that, landfills that just let it vent out to the atmosphere. And then even below that, landfills that really aren't engineered operations at all and have higher risk for affecting the environment and the people around it. And I talk badly about landfills all the time because they're really the symbol of the failure of the linear economy and what we want to be working against. But there's so many things that a landfill can accomplish that would not be accomplished by not having the landfill there. So if you're going to have a landfill, it should be a landfill that operates well and protects the environment and human health as much as possible. So I'm going to just show you some headlines. What can happen when landfills are not run as they should be run and are being designed to run in modern regulations and engineering practice. So on screen here, this is an article about groundwater contamination, specifically with PFAS, one of those emerging contaminants that we've talked about briefly. So groundwater, huge concern for landfill. When we put waste into the ground, the groundwater resource in the ground is something we're very concerned about, and a lot of our design and monitoring surrounds. We're also concerned about surface water. So it's not just groundwater. We can contaminate surface water with seeps out of the landfill or water that contacts and flows into a surface water body. We're also concerned with geotechnical factors. So landfills are these huge construction projects that are going on for years and years and years, and they need to be engineered in a way that they actually don't just fall apart and kill people or damage infrastructure or cause environmental problems. And that's not just a problem. This article is in Ethiopia. It also happens in places like North America. And going back to some of our earlier comments, looking at triple bottom line and who's affected by solid waste solutions, often waste infrastructure is sited near marginalized neighborhoods, low income, racialized indigenous communities. And that's something similar we see with some problems with landfills. Fires is another thing. this is a huge air quality problem. And if you check out this clip, there's some pretty incredible footage of this whole landfill on fire. So just because we're putting a lot of waste in one place, one of the worst things that can happen is it catches on fire. So there's part of operations built around preventing those. And then things like odor can just seem like a nuisance if you're just going there to drop off some waste. But if you live next to a landfill, it's something that can really ruin your quality of life and be something that's a really top of mind concern. The way that we describe or define contaminants in Ontario includes things that are just a nuisance. Even though it's not killing you physically, it can be destroying your quality of life. And again, that's something that may be disproportionately put onto marginalized, low-income Indigenous communities and places like that. So all kinds of things that can go wrong with landfills. So what we want to do with a landfill, minimize harm to human health and the environment. We want to keep our greenhouse gas emissions down, protect the groundwater, protect the surface water, prevent fires, and minimize those nuisances like noise, odor, dust, and pests. We also want to minimize the cost, hopefully so that we can spend more money on all those things upstream of the landfill. And since we have limited space to put landfills, they don't go away, they're still there. We want to use that space very efficiently, which also helps save on cost. Another big part of cost is the amount of leachate that those landfills produce. So part of the design and construction is around minimizing the amount of leachate that we have to treat afterward. And then lastly, we want to, as possible, try and support some of those efforts higher up on the waste hierarchy at the landfill with diversion and valorization. So most landfills you go to will have programs and facilities there focused on diversion and valorization of waste and not just putting it in the ground in the landfill. So public drop-off areas will often have, like if you go to the Waterloo landfill, you can drop off building materials to be reused, bicycles. They have a public education center where you can go learn about the landfill. And then energy recovery is another aspect of landfill. So landfill gas utilization, which we've touched on earlier, and we'll look at how you actually extract that landfill gas in this part. So, you know, when people think about waste, they think about landfills. It may be the only place that they've really encountered waste, aside from their own bins going out on the curb. So there is a lot we can do at landfills to start kind of working them out of their job of the place where we put all our waste. And that's what we'll be going through in this chapter of the course. In Ontario, we've touched on the main regulations way earlier in the course. Ontario Regulation 232/98 under the Environmental Protection Act is a very comprehensive regulation about landfills in Ontario. Now the date is 1998, so sites that are older than that and haven't expanded since then will operate under an old regulation, 347, but I'll focus on the new ones, and it's really comprehensive. So if you open up this regulation and take a look, they'll talk about how to design the landfill, how to operate it, what you have to monitor. They'll talk about financial assurance to make sure that your landfill can be operated and cared for the, could be dozens or over 100 years once it's closed, reporting to the Ministry of Environment, Conservation and Parks, and it looks at all these technical areas, soil, water, air, it's everything. It's really comprehensive, and I'll touch on parts of this regulation as we go through the material to show you some of the highlights and where the regulation affects what we do at landfills most. And since there's so many things involved in landfilling, it can be hard to talk about one part without knowing how it fits into all the other parts. So I'm going to start this landfill unit with just an overview of what is all going on at this landfill site. There's a lot of pieces, and then we'll zoom in and look at each little part. So on the picture here on screen, this is Toronto's Green Lane landfill near London, which we've talked about a couple times. And just looking at it, you can see some of the parts. So there's a complex over here with some buildings. There's this green part that is closed already. And then there's this whole part that's under construction. And you can see there's excavation going on and landfilling operations and lots of stuff going on. So it's important to just see how all these things fit together and what's all happening. So landfills will have a mound of waste that's being built up over time. So it's a constant construction project. And as you saw with the previous kind of geotechnical risk news headlines, this needs to be engineered in a way that it's not going to fall apart. So there's regulations on the slopes and the thickness of the cover and things like that. Then there's a final cover system over the part that's closed. That's meant to keep the water out of the landfill and the landfill gas in. There's a landfill gas collection system that's meant to maximize the amount of that methane we can pull out and use, or at least destroy, rather than venting it off to the atmosphere. We've got a flare or a landfill gas utilization system to do something with that gas. And then on the bottom, there's the leachate collection system. So trying to prevent all the moisture and leachate that's collecting out of the bottom of the landfill from going into the groundwater. And then we have a system to deal with that leachate once it's collected. If the groundwater table interacts with the landfill, if it's at the same level, we might have some extraction wells or barriers to separate the two. Stormwater management, just like any site, an urban site, whatever, we need to manage at the landfill. And there's increased risks because we've got leachate on site and trucks coming in with waste and things like that. And then we have all these environmental monitoring systems to make sure that our groundwater, surface water, air, soil vapor is all at acceptable levels with respect to being affected by the landfill itself. Here's a figure that shows some of those pieces all together. And then in my next video, I'm going to construct a little landfill so you can see how it builds up over time. Because this figure here just shows you a completed landfill. But landfills, they're most of their life, they're being worked on. So it's a continual construction project. You're always building new cells, filling the old cells, covering the final cover on parts that are finished, expanding the landfill gas extraction system, expanding the leachate system. It's constantly moving, so it's hard to really get a sense of what's going on at a landfill just by looking at a static picture of it. So in my next video, I'm going to build a landfill for you, and you can see how some of these pieces would be added over time and how this would scale out. And hopefully it makes you appreciate the complexity of operating a landfill.